Hello, everybody. I'm sure many of you know that this has not been a very good year for Alaska so far. This was an article on Washington Post highlighting that Alaska is baking in an exceptionally toasty March as steep long-term warming presses on. News like this one appearing on Twitter just a few days ago, highlighting that based on average temperatures from March through May, this has been the warmest spring of record for Alaska. 1998 was the warmest to date. 2016 exceeded that, and now 2019 exceeded that. Based on data from the National Snow and Ice Data Center, Arctic sea ice extent for April 2019 was the lowest for any April on record. And looking at May, was the second lowest for that month in the satellite history. And you see here that there is notable change, particularly in the southern Chukchi Sea. And some preliminary studies suggest that this is because of weaker than normal ice throughout the winter, but also because you have more warm water transported through the Bering Sea, from the Bering Sea, an ice-free Bering Sea, through the Bering Strait into the Chukchi Sea. The Arctic of today is indeed a new environment. We've been measuring significant increases in summer SST over the past 50 years. Not only change in the sea ice extent, but also changes in the ice season length, resulting in changes in seasonal processes, and we're going to be discussing about that more during our session tomorrow. These have been resulting in increasing light penetration in the ocean, affecting primary productivity, changing food web dynamics. Permafrost is thawing. In Arctic rivers, flows are changing. Coastal erosion now at rates as high as 25 meters per year, resulting in an annual release of up to 46.5 teragrams of organic carbon, which is of similar magnitude as the annual CO2 emissions from terrestrial permafrost. Extreme biophysical changes are now the new normal in the Pacific Arctic. Ocean acidification, changes in biodiversity, expansion of harmful algal blooms in the Arctic. Both the land and the ocean in the Arctic are changing, and there have been a number of ground-based monitoring programs focusing on measuring this change. The problem is that most of these ground-based monitoring programs focus either on land or the ocean. These are interconnected systems, intrinsically linked, but we know surprisingly little about their interactions, exchanges of materials, energy, water, and how these exchanges affect sea ice formation, ocean salinity, food web dynamics, primary productivity, larger scale ocean circulation patterns. Also, the Arctic coastline is remote, difficult to access, so most existing ground-based monitoring data sets are limited in their spatial and temporal extent. Now, remote sensing observations provide this unique capability to get an integrated coastal Arctic system perspective that you simply cannot get with surface measurements alone. And this unique perspective is exactly what drives ArcticCOLORS. Using a combination of remote sensing observations from satellite sensors as well as aircraft instruments, and combining this with ground-based measurements as well as models, coupled land, ocean, ice, atmosphere models, coupled physical biogeochemical models, the objective in ArcticCOLORS is to quantify the coupled biogeochemical ecological response of the Arctic nearshore system to rapidly changing terrestrial fluxes and ice conditions. And we would like to do that in the context of both environmental as well as climate change. Now, we've been discussing about ArcticCOLORS over the past 5 years. And over the past 5 years, since 2014, we've had a science plan. There's been a science team with international participation. And this science team has been critical towards developing the key science questions for ArcticCOLORS, as well as leveraging existing ongoing activities in the Arctic. We had several presentations, meetings, town halls, sessions at conferences, outreach materials, and you can find all of these at the project website. Now, today I'm going to be providing a little bit more information on updates. What are the revised top-level science questions, the revised study domain for ArcticCOLORS, the potential timeline, as well as information on what's next, where do we go from here. Now, to remind you, we had a kickoff meeting back in January 2014, and right after that, 2 science team workshops. And these were very important towards developing the first science plan for ArcticCOLORS. That was submitted to NASA in September 2015, and there was a panel review in November that year, and we got comments back in February of 2016. And the major comment there was that an Arctic field campaign would be an important and timely opportunity for NASA because of the rapidly changing Arctic environment. Of course, they came back with comments, suggestions for improvement, and we had an open community workshop here at Woods Hole in July 2016. And right after that, a number of town halls and meetings based on which we revised the science plan for ArcticCOLORS, and we submitted that to NASA, and they had another panel review last November. Based on these comments, now the ArcticCOLORS science plan is almost ready for final public release. With the revision of the science plan, the overarching science goal for ArcticCOLORS hasn't changed. It's still to quantify the coupled biogeochemical ecological response of the Arctic nearshore system to rapidly changing terrestrial fluxes and changing ice conditions. But we revised the science questions. We tried to make them more specific, more targeted. And here you see the revised science themes for ArcticCOLORS. The first one focuses on the effect of land on nearshore Arctic biogeochemistry. The second one on the effect of ice. And the third one on the effects of future change, warming land and melting ice on nearshore Arctic biogeochemistry. And this will be addressed mostly with model simulations. Under science theme 1, we really want to quantify how freshwater, carbon, nutrients, sediment fluxes to the coastal zone are changing. And we are focusing here on responses to 4 main drivers: changing riverine and groundwater inputs, passage through transformation zones, these critical points in ecosystems that have a disproportionate biogeochemical influence on the ecosystem but still remain understudied, coastal erosion, and thawing permafrost. We really want to characterize these changing fluxes and how they affect nearshore Arctic biogeochemical and ecological processes. And here, by ecological processes, we are focusing on phytoplankton and their associated microbial loop. We also want to understand better the relative magnitude of inputs from rivers and coastal erosion and how this has changed seasonally and interannually. For the effects, regarding the effects of ice, we want to understand how flow alteration, channeling by morphological ice conditions impact terrestrial fluxes, and how they also affect physical processes, light availability and water mixing, and through these changes, biogeochemistry and ecology in the coastal Arctic. We want to understand changes in coastal snow and ice cover, and how they impact physical and biogeochemical processes, how the timing of sea ice formation, retreat, duration of sea ice cover, how these affect Arctic biogeochemical and ecological processes as well. And regarding the third science theme, effect of future change, here we address both seasonal and interannual timescales as well as interdecadal timescales and bridging this gap, addressing this question across scales, across the temporal, spatial scales. Of course, it's a major challenge, and we're going to be discussing about that also during our session tomorrow. One of the questions from the review panel was, why do we need such a broad range of experimental sites in ArcticCOLORS? Should we revise that? Should we justify better? Should we prioritize? In the revised science plan, we decided to keep the study domain the same. It still extends from the Yukon River all the way to the Mackenzie River, from the head of the tidal influence to the coastal shelf. And we decided to do that because we really want to address these science questions across a wide range of conditions, across a range of environments, from large globally important rivers such as Yukon and Mackenzie, but also include these regionally important rivers, these smaller tundra rivers, include coastal lagoons, include erosional bluffs. And we also want to better characterize processes, of course, along the North Slope here, but we want to quantify better the influence of freshwater fluxes from the Bering Sea through the Bering Strait into the Chukchi Sea and the Arctic Ocean. We will be addressing this, we will be studying this region, this large study region, through a combination of intensive sampling as well as synoptic surveys. And the objective with the intensive sampling is to really understand the processes, because we really want to develop these new parameterizations for models appropriate to capture biogeochemical exchanges in the coastal Arctic. And we want to understand the processes and have these detailed observations, core process measurements across a range of sites, because we also want to develop these new remote sensing algorithms that are specifically developed for the coastal Arctic environment. But in the revised science plan, we also decided to include some prioritization. We have tier 1 sites. For example, you see some sites here with a black outline that are the highest priority, and we have some tier 2 sites, medium priority, in case we need to descope. We didn't want to compromise here in terms of seasonality. We really want to have measurements from spring to summer to fall, over an extended different seasons, because we want to characterize seasonal processes. And some of the conditions we were observing in the past in May are now observed in April or March. So we want to capture these chains, and we would like to have measurements from early March, end of winter, to May, June, where we see the ice breakup, peak river discharge under ice blooms. In July, where we have increasing biological photochemical activity. In September, where we have lower river discharge, but we have this maximum open water area, minimum sea ice extent, and peak respiration, all the way to the freeze-up period. Survey studies, the objective here is to assess spatial heterogeneity, really link and determine link and distance interactions between shallow waters and the coastal shelf. We want to evaluate the models across a range of conditions, across a range of environments, and also use remote sensing observations to scale up, and also evaluate the remote sensing algorithms across a range of conditions. To have a field campaign of the scale of ArcticCOLORS, we understand we need to have a multidisciplinary, multi-method, integrative approach. And as we were discussing in the science plan, this is not a traditional oceanographic campaign with just a few major cruises. We're going to have measurements from different platforms. We're going to have measurements year-round as much as possible to capture some of these seasonal processes. And you see here some examples. Of course, different platforms to have measurements in shallow waters as well as the coastal shelf. And here, central is remote sensing observations from aircraft as well as satellite sensors and models. ArcticCOLORS provide an amazing opportunity to develop partnerships with other agencies. NOAA, BOEM, USGS, DOE, NSF, and we already started working with NSF. For example, we're collaborating with their NSF LTER Beaufort Lagoon site. And we're working with Canadian collaborators as part of the Polar Knowledge and the Sentinel North program, an opportunity to link to other NASA programs above and other NASA activities, as well as develop other international partnerships. All this is summarized in the ArcticCOLORS revised science traceability matrix, which is traceable, has a modular structure, and as any other, STM is very difficult to read. Here is a national timeline for ArcticCOLORS. This is where we are right now. The next step would be to have an implementation team to work more on the implementation plan for ArcticCOLORS. And right after that, we envision having 3 phases. Phase 1, including some preliminary work, maybe developing some repositories of field data sets as well as remote sensing data sets and some initial models. And then phase 2, that would include field work, remote sensing algorithm development and development of models. We envision having 2 phase 2 periods, 4 years each, with 2 years of intensive observations each, so that we can have 4 years of continuous measurements. And then right after that, a phase 3 for synthesis of activities. Most likely this would be a 2-year phase, 2-year period. And based on this notional timeline, some of these activities may start as early as 2022-23 maybe. It depends on a number of factors. But a timeline such as this one would allow to have some nice overlap with above, nice overlap with existing ongoing activities in the Arctic, such as the NSF, Beaufort Lagoon, LTER, and of course, we're looking forward to this overlap with PACE. So this is where we are right now. What's next? As we said, next step would be moving forward, the implementation plan, developing, defining an implementation team that would work on the implementation plan. And stay tuned, there's going to be more information coming up for that soon. In the meantime, what can we do? The finalized science plan for ArcticCOLORS is going to be posted on our website, most likely later this fall. Please review the science plan. Contact ArcticCOLORS PIs with any comments you may have. We have ArcticCOLORS PIs here. Margie is here. Patty is here. Please come and talk to us about ArcticCOLORS. But more importantly, maybe talk to the program managers. Talk to Paula, to Laura, to Jackie, and highlight your interest in participating in this activity if you're interested in contributing. Thank you.